Most of you that doesn't apply to, remember that. Most of you are gonna be just fine. And we're gonna be at graduation, we're gonna be celebrating. It's gonna be so much fun. All right. Logarithms. I'm gonna be honest. As I was going through this lesson, I said to myself, why? Why are we doing this? It's really not hard. It's just steps to remember. That's what it is. They have given you all the algebraic rules of the product property of converting logarithms from one form to another. That's really what we're doing today. We're just taking a logarithm here, for example, A, that is condensed and expanding it. It means the same thing in either form. So if we were to do that, here's what we need to recognize. With this logarithm, well, first of all, let's see if we remember. Do y'all know what base logarithm this is? Double it. 10. This logarithm is base 10. Turn your worksheet over. Look at this example that I'm pointing to right here. Now, what base is this? 2. Yeah, that little tiny number, that tells you what base logarithm you're dealing with. So this is a base 2. What is this log base here? 5, okay? So now we're going to go back to our example here. They don't have a little tiny number there, do they? Anytime that's the case, it's base 10. Every single time. It's so commonly used in mathematics and engineering or whatnot that they don't put base 10. It's so common. So if you don't see a base, it's base 10. Anyway, I wanted to let y'all know that because you might see something like that on Delta Math that you would need to be aware of. So anyway, this logarithm right here has 3 terms, a 5, an x that's being squared, and a y. This is a multiplication problem, kind of, okay? And logarithms and logarithms and exponents are inverse operations of one another. So the same rules kind of apply. And the multiplication rule of exponents states if you're multiplying exponents, you don't really multiply them, you add them. Very good. So if we have these 3 terms here, 5, x squared, and y, that we're adding, if we're going to expand it, it's going to look like an addition problem. So it would simply look like this. Log the 5th plus log x, don't worry about the square for now, plus log y. We've just expanded it. Now, you may be asking yourself, well, what about the exponent here? The power rule of exponents is if it's a power rule, you're multiplying. So anytime we have an exponent, we're going to write it in front of the logarithm as if we're multiplying it to the logarithm. So 2 times logarithm of x, 2 times log of x. That's pretty much what that says. So if you have an exponent and you're expanding, just move it to the front of the word log. That's all you got to do. That is your example for A. That's it. We're just rewriting today. We're not really solving much of anything, I don't think. I think that's probably next class. Okay, here we have a natural logarithm. This is a division problem. And if we're dividing exponents, what are we really doing? Remember, subtracting. Okay, so this is going to look like a subtraction problem. I'm going to write a little note here because a square root is the exact same as a 1/2 power. So if we're taking the square root of x, that is the same thing as x to the 1/2 power. If you were taking the cube root, that's not a very good cube. If you're taking the cube root of x, that is the same thing as x to the 1/3 power. That's going to help us with this problem whenever we expand it. So rather than writing the word log this time, we're going to write ln. I'm going to go ahead and write 3x minus 5 in parentheses. Now, since that is a square root, we're going to want to put 1/2 right in front of ln. Minus ln of 7. That's it. We've expanded it. Yes?
Wait, so if square root x equals x to like 1/2, why put the 1/2 in front of the ln instead of making it 1/2? like exponent.
Can you ask that one more time, please?
So you know how you said that like square root x equals x to the 1/2?
Yes,
Why would you put the 1/2 in front of the ln instead of just
okay,
putting in an exponent how you did?
okay, so a square root is also a power. And the power rule of exponents states that if we have a power to power, we're actually multiplying the numbers.
The exponent's always in the second of whatever.
That's one of the way of looking at it.
Yeah, okay.
Okay, so that is your example, that is your answer for example B. Example C, here we have another subtraction problem. That's gonna look like a subtraction problem at least. So starting here, I'm gonna expand this portion. I'm gonna start with a 2. Then the word log base 3 of x. Well, you know how on the previous examples I did like here? I did that part last. Doesn't matter. You can do it first, you can do it last. You just gotta make sure you have a power that goes in front of either the word log or the ln or whatever. Okay, and now minus. Y'all try this bottom one. Which I got. Since we have a cube, it's gonna go in front of the word log, and x minus 1 would be here. That's it. Just rewriting. Okay, D. How about you try D on your own? We've kind of done something similar to this one already. It's very similar to example B. Bless you. Okay, let's see how we did. 1/2 ln for x plus 1 minus ln 8. Yes. There you go. See, we're just rearranging. Good job. Okay, now we're on example 2A. Now we're going the other way around. Now we have an expanded form that we're going to condense. So start with the word log. Now I'm going to write this x here. And I'm going to give it the power of 1/2. Now this is a subtraction problem, right? So that means when we condense it, it's going to be division. And then on the bottom of our division symbol here, we would have x plus 1 cubed. Now here, is there another way we could have written this? Square root of x. Either way is fine. Whatever you chose to do, that's okay. Both are acceptable. So if you have square root of x here, that's fine. Example B, do we have a subtraction? Do we have a multiplication or division problem here? Multiplication, excellent. So let's start with ln. We have an x plus 2 that is being squared. And we just simply need to include an x now. If you were to put it here or here, I would accept either, but usually we would probably see it here. And that's it. And if you wanted to wrap this all in parentheses, you could, but if you left it without the parentheses, I'm okay with that also. Okay, once you write that one down, give example C a shot. If you're not getting these, but you're trying them, and you're making mistakes, that's actually a really good thing. That's how you get better at math. You try it, make a mistake, see where it went wrong, like, oh, okay. And then your brain triggers like, okay, I made a mistake here. How am I going to correct that next time? It's actually good. So if you're trying, you're not getting them, that's fine. Try to figure out where you're going wrong and then patch it up. Okay, let's move on to the back page. Example D is a little bit different. Do we have we're gonna look here in the brackets. Is this division or is this multiplication? It is division. So sometimes I like to just go ahead and write my division symbol. Now, what I would like for you to do is write what you think goes on top and write what you think goes on bottom. Okay, we get that? And then simply take that 1/5 and everything is being raised to the 1/5. That one was a little trickier.
So you couldn't like do, 5 and then do the group.
You could do that too. Yeah. You would do it over the entire thing. You just do that entire thing would be the 5th root. You could do that also. If you have that, that is an acceptable answer. Very good. All right, for example, E. Here we have division once again. Log base B. Now we have some terms here that we can factor. So I'm going to go ahead and factor this. That's a difference of perfect squares. Here, the multiples of 12 that add to get 7 are 3 and 4. If you can simplify, leaving us with our final answer. If it is subtraction, that's division. If it's addition, that's multiplication. If it's addition, it's multiplication. Very good. 1 through 8, you're going to have some examples on your delta math that are very similar to this. They're just going to be true false scenarios. And I think that if you write these down, it'll probably help you go through them pretty quickly. So for example 1 here, they ask us log of 3 plus 5. We're going to go ahead and add that. That's 8. And then we have log of 3 plus log of 5. That's multiplication, right? That's the expanded version. So the condensed version would be 3 times 5, which is 15. So not the same. False. Okay, here we have log of 9. Here we have a division problem. I'm going to write it up here. We have log of 36 over log of 4. What would that reduce to? Log of 9. Very good. So this right here would be a true statement. True. 3, true. What is 2 cubed? 8. That one's true. Okay, 4, this one's false. Because yes, they are saying log 4 plus log of 7, but remember that would be if we condensed it a little bit, that would actually be 4 plus 7. So not the same thing. 5, what do you think? No, very good. If we were to rewrite this one here, we could rewrite it like that. This right here, that is not the exact same thing, so false. 6, does anybody know what 3 to the 4th power is? Actually 81. Yeah. But thank you for playing. I appreciate the participation. So this one's true. And the only reason why I know that is because I've been doing 3 to the 4th power for a very long time. I haven't memorized. Huh? You see this 4 that's in front of the log here? You could swing it right there. That's another way of rewriting this logarithm.
This 4 on base.
4 would not be the base. This one would be a base 10. Now, for a logarithm, for it to be a base, like look here, right there. You see it has a really small 5. That's how you can identify a base easily with a logarithm. It's a very small number.
So you always have to write front that.
Say it again.
You always have to write front that.
That is one way to solve them. This one would be true. 8 minus 6 is 2. This one would be false because the way that we would want to write that one would be, let me look at it. Minus 2. So not the same thing.
We're gonna need to, know. The 4.
Hmm?
Like we're gonna need to know the series of kind of stuff like that. Like, we're gonna-
I don't know. I don't know yet. I don't know. But if we cross, when we get to that bridge, if we need to cross it, we'll cross it together and I'll show you how to do all that stuff. All right, last thing that we're gonna go over. Need a bigger sheet of paper. Don't like how small this is. Okay, we are rewriting, converting exponential into logarithmic form. And it follows a particular pattern. I prefer, like for example, I prefer it to be written in this manner. I like my, whatever is being squared or cubed or fourth, I like that to be on the left side of the equal sign. Because this 5, that represents our base. So if we're going to convert this to logarithmic form, first thing, let's write the word log. If this is our base in this example, it's also going to be the base here. And then these two numbers simply switch sides. So here, our base that is being squared is 5. Here, the logarithm has a base of 5, and then simply just switch the numbers. That's it. That's how you convert from exponential to logarithmic. So showing you that, let's take a look at D. The reason why I showed you that one is because I don't necessarily like the way that they wrote it here, the way they set us up. They switched it. Okay, so now I've rearranged it. See if you can figure out where those 3 numbers are supposed to go now.
Wait, which one?
This one here. For example, D. In this example, our base that is being raised to the 2/3 power, that is a base of 8. So is also going to be our base here for the logarithm. These two numbers, they're just going to reverse roles here. Yes, no, good. Okay, try E. That would be your answer. Please submit your notes on Canvas. Your Delta Math assignment is ready to go. If you need any help, let me know.